After contributing numerous important findings on the boundary between Earth's atmosphere and space, the Ionospheric Connection Explorer, ICON mission has ended. Launched in October 2019, ICON completed its 2-year mission goals by December 2021, and then operated for an additional year in an extended mission. Joseph Westlake, director of the heliophysics division at NASA's headquarters in Washington, stated, "The ICON mission truly lived up to its name. ICON not only successfully completed and exceeded its primary mission goals, but it also provided critical insights into the ionosphere and the interaction between space weather and terrestrial weather." The ICON spacecraft studied a portion of our planet's outermost atmospheric layer called the ionosphere. From there, ICON investigated how events such as weather from below and space weather from above affect the ionosphere. The ionosphere is the lowest boundary of space, located between 55 miles and 360 miles above Earth's surface. It is a sea of ionized particles consisting of a mix of positively charged ions and negatively charged electrons called plasma. This dynamic and dense region of space hosts many satellites, including the International Space Station, and serves as a channel for radio communications and GPS signals. Satellites and signals can be disrupted by the complex interactions of terrestrial and space weather. Studying and understanding the ionosphere is crucial for comprehending space weather and its impacts on our technology. The ICON mission achieved unprecedented data on the ionosphere, capturing images of one of its most striking features, airglow, and directly measuring the charged gas in its vicinity. ICON tracked the colorful bands moving through the ionosphere. Airglow is created similarly to the aurora, but unlike auroras typically found at northern and southern latitudes, airglow occurs worldwide. Although usually faint, ICON's instruments were specially designed to capture even the weakest airglow, creating a picture of the ionosphere's density, composition, and structure. ICON's comprehensive view of the upper atmosphere provided valuable data for scientists to analyze for years. For example, its measurements showed how the 2022 Hunga Tonga Hunga Ha'apai volcanic eruption disrupted electrical currents in the ionosphere. Immel noted, ICON was able to capture the speed of the volcanic eruption, allowing us to see directly how it affected the movement of charged particles in the ionosphere. This was a clear example of the connection between tropical weather and ionospheric structure. ICON showed us how events in terrestrial weather have a direct correlation with events in space. Another significant scientific breakthrough was ICON's measurements of the movement of ions in the atmosphere and their relationship with Earth's magnetic field lines. Immel remarked, "It was truly unique. ICON's measurements of ion movement in the atmosphere had a scientifically transformative impact on our understanding of ionospheric behavior. With ICON's help, scientists better understand how these interactions drive a process known as the ionospheric dynamo. The dynamo, located at the bottom of the ionosphere, had remained a mystery for decades due to its challenging observation conditions. ICON provided the first concrete observations of the winds fueling the dynamo and how it affects space weather. Unpredictable terrestrial winds move plasma around the ionosphere, causing charged particles to be ejected into space or fall toward Earth. This electrically charged tug-of-war between the ionosphere and Earth's electromagnetic fields acts like a generator, creating complex electric and magnetic fields that can affect both technology and the ionosphere itself. Immel said, "No one had ever seen this before." ICON finally and definitively provided experimental confirmation of the wind dynamo theory. On November 25, 2022, the ICON team lost communication with the spacecraft. Despite using an onboard command loss timer to perform a power cycle reset, communication could not be reestablished. Although the spacecraft remained intact, other troubleshooting techniques also failed to reconnect ICON with mission operators.